Hello, dear students. Today we have proposition, I guess it's 12. I forgot if I did the right one. Yeah, I think it's 12. To circumscribe an equilateral and equiangular pentagon about a given circle. Circle, circumscribe a figure. What kind of figure? Pentagon. What kind of pentagon? Equilateral and equiangular. Okay? To help us out here, let us conceive that there's already been constructed, inscribed, should I say, inscribed in the circle, a pentagon. And these are the points. These are the points of that, where that pentagon comes into contact with the circle, say, okay? So just imagine this pentagon. Great. All right. Now, let's take the center of the circle. Let's drop lines to the points of contact where that inscribed pentagon came in contact with our beloved red circle. Say, okay? Great, now from the points of contact, let's drop perpendiculars. Let's make perpendiculars. Okay, clean this up a bit. Now we have a good looking, not beautiful, but a good looking pentagon. Now it's required to show that this pentagon is equilateral and equiangular. Okay? Let us then connect these 2 points here, the straight line, and these 2 points here with the straight line. No problem. I'm going to get rid of these, I'm going to dash this up. I'm going to get confused, okay? And then I'm going to dash these things up. Okay, so here we have 2 triangles. Oh, by the way, remember we made these right angles? That's important. And we know because they're right angles that these lines, coming from the diameter, these lines touch the circle. So all these lines are tangential. So this figure, is a 5-sided figure, is certainly circumscribed. We know that much because all these lines touch it. We know they touch it because the lines come at right angles from the diameter. We prove that, therefore they touch it. Great. So here we have 2 triangles, and they're both right angle triangles. Okay? Therefore, in this triangle, the square on the hypotenuse is equal to the squares on the sides. And in this triangle, the square on the hypotenuse is equal to the square on the sides. But the square on the hypotenuse is on the same line, so the 2 squares are equal to each other. Therefore, 2 things equal to the same thing are equal to each other. Therefore, square on this and the square on this, square on this and the square on this are equal to the square on this and the square on this. But these 2 lines are diameters, radii, each radius of this circle. Therefore, the lines are equal. Therefore, the squares and the lines are equal. Therefore, we can take equals from equals, and the remainders are equal. The square on this is equal to the square on this. Therefore, this line is equal to this line. That's what we wanted. Okay? Now we can say we got 2 triangles, side, 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 this side and this side equal to this side and this side, and the side they contain are equal. Therefore, the remaining angles are equal, namely those which tend to equal sides. These 2 sides are equal. Therefore, these 2 angles are equal. These 2 sides are equal. Therefore, these 2 angles are equal. Great. We can do the same thing over here with these 2 triangles. Right angle triangle, hypotenuse, blah, 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 equal, equal, and equals with side, side, side. So let's do it with a different color just to make sure we don't assume that they're probably going to be equal, but we don't want to assume that they're equal. Great. Now, because these 2 are equal, this whole is double half of one of them. Because these 2 are equal, make up the whole angle is double one of them. Each of these are half of the whole. Likewise over here. Okay? Now, let's show that this angle is equal to this angle. We know that these are points of the equilateral pentagon that we talked about earlier, and therefore this line would equal this line. And therefore the circumference, which those lines subtend, are also equal. We prove that. And equal lines are subtended by equal circumferences. Therefore, these 2 circumferences, we already know they're equal because we inscribed the pentagon. Great. Okay, now we know that angles coming from the center on equal circles and equal circumferences are equal. This is the same circle, so therefore the circle is equal to itself. This circumference was proven equal to this circumference, therefore this angle is equal to this angle. Great! But, now, good, so we got, this whole angle equal to this whole, and therefore the half is equal to the half. Great, so I got this angle here equal to this angle here. Now, let's look at these two triangles. We've got side, angle, side. Do we have that? We got angle, 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 angle. So we got this triangle and this triangle. Angle equal to angle, and angle equal to angle, and side equal to side. It's the same side. Therefore, I have two triangles with angle, side, angle equal to angle, side, angle. Therefore, the base is equal to the base. This beautiful little line is now equal to this beautiful little line, okay? The triangles equal to triangles, etc., etc. But look, just as we proved this was equal to this, we said likewise we can show that this was equal to this. We did that earlier. You can look at the beginning of the proposition, okay? So, we got this also being equal to this. Therefore, the whole is double the half. Okay, so this whole thing is double this. But this, and likewise over here, we can prove that this whole is double this. But this, just by showing side angle side over here as well. Sorry, angle side angle. Therefore, since this is equal to this, and this is double this, and this is double this, this is equal to this. That is to say, this side of the pentagon is equal to this side of the pentagon. Likewise, we show that this side of the pentagon is equal to this side of the pentagon, equal to this side of the pentagon, equal to this side of the pentagon. Therefore, this pentagon has been proven to be equilateral. Now let's show it to be equiangular. Okay? So we got these two things here. Okay? So we got side, angle, side equal to side, angle. No, we don't have that. We've got angle, side, angle, angle, side, angle. Therefore, like we showed, the triangles equal to triangle, the remaining angles equal to the remaining angles. Therefore, this beautiful red angle is equal to this beautiful blue angle. But this big old angle was double this angle, and this big old angle was double this little angle. Well, the halves are equal, the doubles of those halves are equal, therefore this angle is equal to this angle. And this is an angle in that pentagon, and so is this. So these two angles in the pentagon are equal. Likewise, we can show that this angle is equal to this angle is equal to this angle, and all these big, beautiful angles are equal to each other. And we already showed that it's equilateral, and we already showed that it's circumscribed because these lines touch the circle. Therefore, as we said in Proposition 12, if there be a circle, it is possible to circumscribe a pentagon which is equilateral and equiangular about that circle. Quod erat faciendum. Bye-bye.